we discussed a bit about the 5G. So first of all, just a very short background about myself. I can relate to some of the stuff that came out here. I started my career as a UAV, unmanned airplane pilot for about 6 years. Then did my computer science, and then I graduated the worst time in history to graduate with a computer science degree in 2001. We already know what happened there. And there was kind of the same mantra, a million unfulfilled jobs and so on. And then I was lucky enough to apply to a job on Munster and got a job with one of the sharks on Shark Tank. And that's how I started my career, and I've been working with startups ever since. But today we have a very exciting topic, and 5G is just another technology, right? We're moving ahead at like light speed, while the the devices and the policies and regulations are kind of sitting behind. So the idea today is to discuss some of the challenges that we have around 5G, and then maybe finish up with a positive note. So Doug Jones will maybe you can provide some background of yourself as well.
Sure. It's interesting that you graduated in 2001. So I graduated in 2001 with materials engineering degree and a public policy degree. Moved up here in August. Was unemployed when the planes hit the Twin Towers in the Pentagon. I lived in Arlington at the time. So sort of changed the world, changed everything we were doing. So since then, I've spent the better part of almost 20 years now working as a government contractor. Started with Lockheed Martin, then moved over to Leidos when Leidos acquired Lockheed Martin's IS&GS division. Most of that early part of my career was large-scale system development for law enforcement agencies, FBI and DHS. So big software side, right? How do you do complex, massive-scale systems in the federal government? And then, but then, I built this massive system that ran on 4,000 blade servers, and they're like, hey, cloud's kind of like that, and you had to figure out how to manage at scale. So I sort of fell into IT. View myself as a software guy, got into IT, and then got convinced to do a little sojourn over to DHS, where I ran the enterprise SOC for about a year, running 24/7 operations. Cyber never sleeps, and spending time with the analysts there on the watch floor 24/7 on holidays, protecting that, dealing with major issues as they pop up, whether they be breaches, whether they be new vulnerabilities, major spills, and then how do you retain that talent, as we just talked about, right? So there's you can't have negative unemployment, but it's pretty close to that in that field when you start talking about the best of the best. And then now at Leidos, I run our digital modernization accelerator out of our corporate technology office. Three main focus areas in that. So it's enterprise IT modernization, cybersecurity, mostly defensive cyber operations, and then Sec DevOps. So that's sort of the three things that I'm focused on, and it's about leveraging our partners, leveraging academia and industry, and then leveraging what we do for all of our customers across the federal government to bring the best forward and bring that innovation at speed while still giving that security that we really need.
Fantastic background. And by the way, I find people that have the technical background, the nuts and bolts and the kind of the bits and bytes, very effective in explaining to the rest of us, some of the problems and issues with technology. So we had a lot of fun discussing some of the same topics last week, and we touched upon one of the kind of the top maybe three issues with the 5G and the 5G technology deployment.
Sure. I mean, it starts with just adoption, right? So a couple of key areas when you look at 5G is it's not one technology. It really is a collection of technologies and solutions that are going to achieve this much more always on, higher bandwidth, greater capacity. And a large chunk of that is the millimeter wavelength technology. From the spectrum perspective, that's where you're going to get that low latency connectivity. But there's a major struggle around that, in that now you're talking about Wi-Fi level density of connections, right? So that gets really, really hard when you start trying to get to those speeds. So how are you going to adopt that out? And we'll go into more of the challenges around that in terms of how you do shared networking in that space, because you're going to talk about people bringing in 5G repeaters and routers into your office buildings, and then who owns those, and how does your traffic dual tunnel across those, and how do you encrypt it and secure it? And that's a major struggle. The other piece you look at that's really exciting about it is it's SDN enabled from the ground up, with a lot of security controls built into it from the standards from the ground up. And that's really exciting for those of us in the industry. So you can do amazing things like slicing of data. So you're essentially doing metadata tagging of data, be able to tunnel it through and be able to segment off and have different rules for it, from edge computing, from a security perspective, and how you can do that built in from the ground up. It also gives scalability in the way you can offload and manage it at scale much more effectively than you can inside LTE, which is not as sort of intelligent built. There's a lot of sort of, I'll say, classic telco repeater type models involved in those. So that's a really exciting piece from a management perspective. And that's some of the stuff that's going to roll out first, is the backend stuff that you won't see as much. And it's going to help with capacity. It's going to help with, as we're having more and more data come in, how do we offload it and do shaping and traffic shaping better? That's what's going to hit first. You're going to see pockets of the higher speed and lower latency, but you're going to see some of the back-end technologies first because it's easier for them to roll out. So I think those are some of the key ones that we're looking at. And then the security from the ground up, they are building encryption from the ground up. So your payload, your primary data traffic, they are encrypting that from the ground up. And we'll talk a little bit later about there's real challenges though, because there's metadata, as we just talked about earlier, so that IMSI code, that's unencrypted. Right, there's other key elements that are unencrypted. Metadata about your traffic that's going through is unencrypted, and now that's a vulnerability, and there are already people there working to exploit those and show potential attacks against us.
It's super exciting. I can't wait to get back home. I have the new Pixel phone waiting for me to turn on the 5G in my area. But we talked about the fact that some of it is marketing, right? There's a 5G that shows up on the phone. It's not really 5G, and majority of people don't even understand what the technology means. One of the aspects of 5G is the ability to have private networks, which basically is multifier. Can you provide an idea of what that is and why is it so exciting for deployment?
Sure. So multifier is a concept of taking 5G technologies, and they're even starting to do it LTE, which is kind of interesting, and deploying it in the unlicensed spectrum. So if you think about 5G, there's licensed spectrum. They had the big auctions out for all the top telcos. They bid billions of dollars for the spectrum, right? So they control it. The 5 gigahertz spectrum is what we run Wi-Fi on, what we run a lot of things, so it's unlicensed. And so what they're doing is taking 5G technology and deploying the unlicensed spectrum. So you can create your own private 5G network and run in that unlicensed spectrum. And the really exciting part about that is when you start thinking about IoT, if you're running an industrial control system or you're running a bunch of other things from an IoT perspective, are you going to run them across a common carrier fabric backbone that you don't control and own? If you start talking about SCADA systems running, highly complex manufacturing or medical device pieces, no, you're not. Instead, you're probably going to run it over across something like this, where you can control it, you can secure it, you own it, and then you decide where it connects back in. And the reason why you would do this over Wi-Fi is it has better security controls built into it than Wi-Fi from the ground up. It's got better SDN type modeling and capabilities for how you can traffic shape it, how you control the latency on it, how you can prioritize different types of traffic based upon how it wants to communicate. So certain devices are more like check-in versus actually streaming data. It's built that in from the ground up. Wi-Fi 6 brings a little bit of that, but 5G brings it stronger. So the excitement around this is how can I build my IoT landscape in a way I could trust from a security professional? And that's a real difference maker that I think that this is going to bring to the table. And it's going to integrate with you're going to connect in potentially to 5G. You may use 5G as a bridge to get back to your enterprise or campus, but I want to be able to control that at the last mile. So I think it's a really exciting technology, and it's about how we're now extrapolating what we've done in 5G and making it more exposed to a lot of use cases that wouldn't trust a carrier to completely own that and be able to determine what you can and can't do from a security perspective.
That's great. And, the security concerns around 5G is, it's paramount, including the government, right? We just heard that the concern around the supply chain of devices around 5G and banning of Huawei devices in the government and the US in general. What are the recommendations that are currently available for enterprise and government prior to deploying 5G?
So it really starts coming down to secure supply chain, right, and trusted supply chain. And that's a real struggle right now because foreign nationals are ahead in this game, right? And as we're trying to move fast, it's becoming a struggle in terms of how do we start adopting these technologies when there's real concerns of are there embedded risks that are built into that, especially when you look at traffic going across. So there's a couple of key things. One, you start supply chain security, and you start looking at what are your trusted suppliers, right? Whether that be trusted foundry level stuff, like potentially from Qualcomm or Intel, or depending on the maker, or are you talking about actual trusted levels that further up the chain? We saw a big controversy of the UK out of this, right? Where they, decided to sign a large contract with Huawei, and the UK government started backpedaling, and now they're sort of in this no man's land trying to figure out what they're going to go do. So that's a big piece of it. I think you're also going to see where it's built in the chipsets. I think the other piece that's going to be really interesting is when you start looking at IoT, you start looking at compute devices, you start looking at your phones, and where are the SIM cards, the type of connections, the radios, where do they come from? And people aren't talking as much about that. They're talking about Huawei, they're talking about the backbone infrastructure, but just as important is the other pieces, because that's going to be a wider attack surface that it's easier to get gray market stuff into. Right? It's going to be harder to get in your backbone routers. People care about that. They track that. We do that today with network routers, although it's one of the biggest attacks in gray market is Cisco and Juniper equipment. But when you think about, it's easier to try to track this because they're smaller, those devices, they're really expensive. We tend to track them, they tend to be centralized control. When you start talking about trying to get gray markets into consumer devices or IoT devices, now you've got real risk integrating across your ecosystem. So I think it's going to go back to how do you trust your secure supply chain, which is a problem we're going to have across the board, and that's going to be a big focus area.
Right. But then there's also an opportunity, right? We talked about the ability to allow for edge computing and fog computing, which is the Cisco term. And we talked a bit about the biometrics, for example. So, biometrics has the ability to detect who you are on the phone, but imagine now the phone will have the ability to process much more information depending on the speed of the network. So again, with any opportunity or vulnerability is also opportunity, right? So what the opportunities are for specifically for 5G computing?
So I think this is one of the most interesting pieces, and it's just the ecosystem, right? So if you think about what we do today, the network is your critical constraint. It's your choke point, right? When you start thinking about, we have data explosion at the edge. We have tons of data, whether it's your Apple iWatch heart monitor, or it's drone sensors, or it's IoT sensors, or it's your alarm system. They're producing gargantuan amounts of data. And you can't stream all that across your network. Even with 5G, the amount of data we're creating is growing exponentially compared to the bandwidth explosion we're trying to get out of 5G. So you need edge computing, and that's what's going to be absolutely critical to start doing this. And that's where some of the technology around data slicing becomes really interesting. So if you have like a private 5G network, or if you have a shared carrier network, and they're talking about exposing the ability to slice your data, so you can say a certain subset of data will only go in this sort of ecosystem and not go out on the backbone, and I can take it off and put on a metro edge computing device, and then I can pre-process it. And then you're going to start seeing, just from a normal edge computing, how do you do that? So I'm taking a bunch of, we'll use a military construct, right? So think about people in the military out in the field. They may have drones, they may have other sensors they have out there, stream back a bunch of data to a forward deploy unit. I can't take that back across. It could be across SATCOM, could be in a rural area, it could be across the dollar areas. I can't take all that data across. I need to forward deploy edge computing, and it could be AI/ML at the edge, could be using FPGA type chips that are optimized for that. We need to be able to do that so we can pre-process the data and only send back what's important, right? Either anomalies or what we want to match on. And that's where I think 5G is going to be really exciting, because it can enable me to get that data locally at the edge very rapidly without going across the backhaul, which gets really expensive, and then do that processing. And that has telemedicine implications. It has implications from a safety perspective for Coast Guard, think rescue missions. It has a lot of implications across when we look at where this is going to be deployed to bring that edge computing. So I think marrying those two together is absolutely critical, because the only way you'll get the benefit of IoT is a combination of edge and 5G. Otherwise, individually, none of them will actually give us the value prop we're looking out of it.
And then you mentioned last week that data is a new oil, right? Which I couldn't agree more. And if we use the same analogy, now with the 5G, we have massive amount of data everywhere. So now, how do we drill for that oil, right? How would we find, what's important out of that, all that, IoT generated data and devices and so on? What do you think?
I mean, that's honestly one of the biggest struggles we've got right now. And then the other thing around that is what do you do with the data? Do you leave it where it is? Do you suck it back across? Is it some hybrid mode, which is probably what it's going to be based on business rules? Because again, you want to, pulling all the data back to a data ocean, a data swamp, a data lake, whatever you want to call it, is really, really expensive in the grand scheme of things and the amount of data we're talking about, right? So you want to leave it there, and you want some subset of data to come back across. This way, the subset, the metadata about your data, will be how you drill, right? That's going to be the equivalent of oil and gas's, geothermal maps that they do, right? And it tells you where to go find that data and only pull back the data snippets that you need across, the ecosystem. So I think that's where we're looking at. I think it's absolutely, that together, these technologies are critical for us to be able to get the advantage out of these types of, leveraging data at the edge, leveraging all the information that we're generating to really solve those hard problems. So I think, data is the new oil. The other struggle I'll tell you is data is also the threat, right? So oil causes wars as well. So when you start thinking about the data you have from 5G, if we go to the millimeter wavelength stuff, they now have location accuracy down to inches because they're having to basically transform that millimeter wavelength and optimize the millimeter wavelength to where you are location-wise. So they know kind of within feet where we are now, but now you're talking about centimeters. What does that mean from a threat perspective? What does that mean from, you start thinking about nation state level threat or understanding exactly what people are doing in privacy and tracking. So there's a lot of concern around that location accuracy from a 5G perspective and what we can do to protect it. And that's some of the conversations that are just now starting to come up around 5G, around privacy. We've talked a lot about encryption and security, but the privacy aspects of location. There's already a ton of data about, like we said earlier, about all of us in this room. That data is already being sold by companies out there, right, in terms of information about people. Now we're talking at a higher level of accuracy that is frankly scary when you start thinking about assassination attempts. You start thinking about other ways that people can take advantage of that. I have down to an inch level of where your phone is. I mean, there's just real concerns we got to think about. And again, that conversation is just now happening.
There's always opportunity for new vendors in the space, right, to protect us, from the vulnerabilities. You mentioned you were at Black Hat, and there was a new vulnerability around the 5G detection, and we're going to continue seeing that. We talked about the fact that the 5G and technologies in general is like, the seat belts, where cars were already going like 60 miles an hour, but seat belts were not available until people got injured. But maybe we should open up the conversation, and maybe there's some questions before we wrap up.
With high bandwidth becoming available in the
Just
devices we carry in the devices.
Why don't we just repeat the question?
With high bandwidth becoming available in the devices we carry and in the devices at our homes, will end users tend to connect directly to the public network rather than going to aggregation points like routers in their homes, or when they're at work connecting to the high bandwidth connection in the office? And when they do, will that create new vulnerabilities and privacy concerns that currently don't exist? If I can get high bandwidth from my laptop from home, I'm not going to connect to so currently you have larger populations of people going through a single device, right, that's local to them. Now you may have people may be tempted, businesses, even when they're at the workplace, to go directly to public connection because it's also high bandwidth. So now you can track individuals. There's no aggregation. What kind of cybersecurity implications will that have?
So I think that's actually a major debate going on in terms of the deployment approach, right? So are we going to have that high bandwidth everywhere? Again, when you talk about the amount of repeaters and sort of 5G installation you have to have, and then if they put it in and say this whole Tyson's Corner area was blanketed in 5G, do I, as a company, enterprise, just use you and then slice through? Do I, and I basically pay Verizon or AT&T or Sprint or whoever to go do that? Do I still want my own because I don't trust that? It's a major issue, and it goes out the comment earlier. It starts moving us to that zero trust model, right? So you have to assume your network is compromised, and that's the whole point of zero trust. You assume your network is compromised, so then you want to create end-to-end encryption and tunneling from the edge device to wherever they're trying to go. And when you think about where enterprises are today, where they like things like a TIC, a trusted internet connection, which is a sanctioned man-in-the-middle attack, those things start going away. Because now I want to go from you on your cell phone directly to the application. Actually, let me clear, not even the application, to the data I want. Because we're moving to a data-centric approach to access it. And how do I monitor that? How do I manage that? And how do I control vulnerabilities? That is going to be the defining approach over the next 7 years for us in the cybersecurity world.
If employees start doing that, it's a global coffee shop, right? So they're taking their own device, they're connecting directly to the public network. I can't see it, I can't monitor it, I can't keep them safe. It's a global coffee shop.
So monitoring is moving to the edge. So the whole concept of network monitoring is going away. If you start thinking about most of our SOCs and they monitor their ticks, what percent of the traffic can they actually break and inspect and look at? You'd be amazed at how little traffic, because of TLS and all the things are end-to-end encrypted, that they can't monitor from a cyber perspective, right? You're looking for data loss, you're looking for vulnerabilities coming out, you're looking for beaconing from an adversary. You can't track those for a lot of things. So what we need to do is we need to change from a network-centric cyber approach to an endpoint and to a data-centric, right? So I care about the data on the back end that they're accessing or the applications, and I care about the endpoint, because you're going to assume, and that's the zero trust model. And we're not ready for that. When you start looking at how do I get log data off of the endpoint, we don't do that well today in most cyber entities, right? Again, we're still network focused. So how do you get that off? How do I protect the endpoint? Now those vulnerabilities of the endpoint are even more important than they are today, because I don't have that walled layer to protect them. So completely agree. I think this is going to be a major challenge for us, and that's going to drive the zero trust conversation, which, by the way, is hard. Anyone thinks zero trust is an easy piece? There's policy, there's identity, there's how do I know what data I need to protect and how, and then there's the whole endpoint. So it's a really hard problem that's going to be an evolution inside our industry, but I completely agree. That's where we're going to have to go, and we as an industry have to figure out how we get creative about that and be smart about the data and how we manage it.
And I would add to that your identity would be even more important, right? So your identity, your device identity, your behavioral identity, right? So if you're accessing, 2:00 in the morning, or you've done something before and the device doesn't recognize you, then you have issues accessing the data. But yeah, all those are going to be very important.
So the other thing I think we're going to get into is less of a binary access. It's going to be risk-based access. So that data, maybe it's PII, maybe it's PHI, maybe it's sensitive. You may not be able to access it depending on where you're accessing it, the time of day you're accessing it. And so that behavioral identity piece may determine the type of data you can get access to. Or you may have to give additional factors of authentication that you normally wouldn't do. So I think we're going to start seeing, right now it's mostly binary. You have access to stuff or you don't. And we're going to start seeing all these other factors, location, time, the state of your device, what vulnerabilities are on your device, determining not whether you can access, but the type of access you have.